The solar heat pump. The three major challenges in the UK's transition to sustainability are our dependence on gas for heating, a lack of electricity storage, and a lack of generating capacity to support the projected rise in electric vehicles and heat pumps. In a warming world, there will also be an increased demand for cooling. Unfortunately, renewable heat is only viable when subsidized. The unit price of electricity is 4 times that of gas, making heat pumps uncompetitive. The efficiency of air source heat falls with temperature, and this can lead to very high running costs in cold weather. Ground source heat pumps avoid this issue, but these cost roughly £16,000 to install. Solar PV systems have a low efficiency of around 12%. To make matters worse, 2/3 of solar generation is exported to the grid during the day, with little benefit to the homeowner whose peak electric use is in the evening. Despite this, rooftop solar PV is nearest to break-even return on investment. Solar thermal can reach efficiencies of 40%, but the collector area has to be restricted to prevent the system from overheating on sunny days. This limits solar thermal to providing hot water only, shaving just £70 off the annual energy bill. The missing ingredient with all these systems is low-cost, seasonal energy storage. Hybridize has applied joined-up thinking to existing technology to develop the solar heat pump. This is a dual-source device that uses surplus solar photovoltaic generation to harvest the abundant air source heat of summer and store it in the ground for winter. Hot water and cooling are essentially free byproducts of this process, as only solar power that is surplus to requirements is used. The combination of ground preheating and source flexibility brings down the size and cost of installing the heat pump's ground coupling. Thus, solar power, energy storage, cooling, hot water and winter heating are brought together into an efficient and cost-effective package. By operating directly from the DC output of a solar PV panel, the losses of a grid-tie inverter are also avoided. Battery storage can also be added to the system as an option that provides off-grid heat and power capability. The solar heat pump is grid interactive. This allows it to provide dynamic balancing of a building's electrical load to renewable generation by varying its own power consumption. The solar heat pump seeks to minimize the import and export of grid power and capitalize on time-of-use tariffs. These concepts are the subject of a searched patent application. The ground coupling is a matrix of short bore holes. These are bored radially from a central access pit, using a pneumatic reversing mole. Installation time and cost are a fraction of conventional drilling methods. The ground loop can be installed in any size garden, or even retrofitted under the building. Hybridize has the IP and design skills required to bring these proven concepts together into one system. The solar heat pump has been designed to work in the cloudy UK, but is equally effective in sunny regions. This provides a huge global opportunity. The unit price is expected to be comparable to a ground source heat pump. The global heat pump market is projected to double over the next 5 years, to $94 billion. This is the only renewable heat solution that is viable without subsidy. Energy use in buildings is a major source of CO2 and was until now an unsolved challenge. For the past 4 decades, North Sea gas has heated the UK. As has happened with coal, the combination of environmental concerns and fossil fuel depletion suggest this will not be sustained beyond the next decade. The solar heat pump is the sustainable heat and power solution for the 21st century.